In an earlier video, we looked at two graphs, the graph of two functions. Y is equal to 1x and y is equal to 2x. Now, let's look at a little bit more to this program in GeoGebra that can plot my graphs for me. So let's open it up. Okay, good. Now let me get rid of some of these writings here and set up GeoGebra so we can use it. Okay, get rid of this. I want to show my grid and the center just about here. All right, good. Now I want the graph of y equals x. Now the program already know that I'm plotting y equal. I only need to type the x part, the part that is on the right of y equal, on the equal sign. So this will give me y equal x. That's my line y equal x. Let me make a little adjustment to my line. Yeah, I want my line to be a thick line. Okay, good. So this is y equals x. Now let's also look at the line y equals 2x. That's y equals 2x. Let me thicken the line, change the color a bit, and make my line thicker. So I have y equals 2x. Y equals 2x is my red line. All right? So this is 2x. Now, what would 3x look like? Y equals 3x. Y equals 3x. Interesting. Let me adjust my line. Okay, so the blue line is y equals 3x. Let's do a little check here. For the y equals x, if I form a right angle triangle between any 2 points on the line, say this is my right angle triangle. This triangle is 1, 2, 3 high, 1, 2, 3 wide. Alright, so in the form y equals mx plus c, this is y equal 1x plus 0 because c, we are assuming that we don't have a c here, it is 0. Now, here, generally, the height of this triangle that you form is called the rise, and the width of the triangle that you form is called the run. And the gradient, m, is equal to the rise over run. Rise divided by run. You see that? Now let's check this for the other lines as well. Y equals 2x. The red line is 2x. Let's draw a triangle between 2 points on the red line. So we come down here and then across. The rise is 1, 2, 3, 4 high, and the run is 1, 2. So the rise over run is 1, 2, 3, 4 divided by, the rise is 4 divided by the run, 1, 2, which is 2. So what we have is y equals 2x. The number that multiplies the x is the gradient. It shows the steepness of the line. Let's look at our other line, y equals 3x, and see if the same thing works out. Suppose we have this line and we've formed a right angle triangle. Let's go way down here and go across. I don't really want to have any fractional values. This is going halfway. I want to be exactly on the grid line. So I'm coming here. Good. Now, our rise over our run. Let's see how much it rises. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 high. So our rise is 12. The run, how wide is it? 1, 2, 3, 4. 4 wide. So 12 divided by 4 is 3. Y is equal to 3x. Alright. So we see that the number that multiplies x gives us the gradient. Let's examine what's happening here further. What we have is c is equal to 0. And I notice that these lines go through 0. Let's look at a different line. Let's get rid of these. Delete, delete, delete. Now, an example of a different line. Suppose we have y equals 2x plus 1. What would that look like? Now, what I would like you to do is plot the graph of y is equal to 2x plus 1 on your graph paper, right? Let me move this here. But for now, we want to see what would happen when we plot y is equal to 2x plus 1. So 2x plus 1. Here it comes. We have it. Now, let's make a bit of adjustment to our line, make it easier to see. And I want the label on it. 2x plus 1 is our line. But you notice that this line, it seems to have the same gradient as 2x. And it passes through 1. So, what we do? Let us plot the line y is equal to 2x. Okay, that's the line y is equal to 2x. Now, let's put on our label on it. The light blue line is y is equal to 2x. The black line is y is equal to 2x plus 1. So we have these so far, right? We have y is equal to x, which is 1x. No, what am I saying? What we have are y is equal to 2x. Then we have y is equal to 2x plus 1. What about y is equal to 2x plus 2? What would that look like? Let's see. I want to plot the line y is equal to 2 x plus 2. So that's our line. Y is equal to 2x plus 2. Make it a different color and thicken it, and I want to show the label. So this line here, this looks like pink, is 2x plus 2. Y equals 2x plus 2. Now let's look at the differences between all three. This can be written as y is equal to 2x plus 0. That's why I didn't bother to put it there in the first place. This is 2x plus 0, and it passes through 0 on both x and y axes. Y is equal to 2x plus 1. And you notice y is equal to 2x plus 0 and 2x plus 1. They have the same gradient, right? But what's the difference? The 2x plus 1 passes through 1. The reddish line, y is equal to 2x plus 2. It will have the same gradient because each of them is 2x. So the rise over run will be 2. But then this one has plus 2 at the end. And you notice it passes through 2. So we can look and see that this number at the end is the point where the line crosses the y-axis. This is called the y-intercept. The y-intercept. That's where the y-axis is intercepted by the line that we plot. All right? So it's the y-intercept. So basically, if we look back at our document here, we see that in the case of y equals mx plus c, let me put it down here. In the case of y equals mx plus c, m is the gradient. So let me highlight that. M is the gradient and c is the y-intercept. At all times that is so. And those are constants. Alright? So that's the general form of a straight line. You have y is equal to mx plus c, where m is the gradient and c is the y-intercept.